Sixth grade, Module 5, Lesson 10, Problem Set. Number 1, how is the length of a side of a square related to its area and perimeter? The diagram below shows the first 4 squares stacked on top of each other, with their upper left-hand corners lined up. The length of one side of the smallest square is 1 foot. Okay, so we're going to complete this chart, calculating area and perimeter for each square. So when the side length is 1, so this little one in the corner here is 1 by 1. So the expression showing the area would be 1 times 1, which would mean that the area is 1. The expression showing the perimeter is 1 times 4, because perimeter is what's all the way around. So it's 1 4 different times, so we do 1 times 4 to find the perimeter. So then the perimeter in feet is 4, because 1 times 4 is 4. So let's do that for the second square. So this green square is 2 by 2. So the area would be 2 times 2, so the area is 4. The perimeter would be 2 times 4, because there are 4 sides. So the perimeter is 8 feet. If we did 3, so the side length of this is 3 by 3, then the area would be 9. If we wanted to find the perimeter, we do 3 times 4, which would give us 12. So then let's do the next size is 4. So this one's 4 by 4. So the area is 16. The perimeter, if it's 4 all the way around, we have 4 times 4, so the perimeter is also 16. So now let's keep going without the images. So if we had a square, a 5 by 5 square, the area would be 25. And then the perimeter, each side is 5, and there are 4 sides, so the perimeter would be 20. If we had a 6 by 6 square, the area would be 36. Each side is 6 times 4 sides. Perimeter is 24. For a 7 by 7, the area would be 49. 7 times 4 sides would be 28. If it was an 8 by 8, it would be 64. And the perimeter, 8 times 4 sides, would be 32. If we had a 9 by 9, the area would be 81. 9 times 4 sides would give us a perimeter of 36. And if we had a 10 by 10, the area would be 100. 10 times 4 sides each will give us 100. 10 times 4 is 40, so the perimeter is 40. If we had n, so n, if the side was n, we would do n times n, would give us the area. So then the area would be n squared, because n times n is n squared. And then the perimeter would be n times 4 sides. And so that would be 4n. So in a square, which numerical value is greater, the area or the perimeter? So when we're looking down here, what is greater? It wants to know the area or the perimeter. So here we have 1 and 4. So here the area is smaller than the perimeter. When we move on to the next one, 4 and 8, the area is still smaller than the perimeter. We have 9 and 12, so area is still smaller. And then when we get here, the area and perimeter are the same. And then it starts to switch when we get to 5. The area here is greater than the perimeter here. Whereas here, the area was less than the perimeter. So there's not one right answer for this. So we're going to say which numerical value is greater? Well, it depends. So let's say it depends. Let's see. If the side length is less than 4, the area, let's say area is less than perimeter. If the side length is greater than 4, or the area is greater than the perimeter. When is the numerical value of a square's area equal to its perimeter? So we already found that one. It's equal when the side length is 4. That's when they're both 16. So I'll say when the side length is exactly 4. Why is this true? Well, it'd be true because n squared is equal to 4n only when n is equal to 4, right? 4 to the second power is only equal to 4 times 4 if we're working with 4. They're both 16. Number 2. This drawing shows a school pool. The walkway around the pool needs special non-skid strips installed, but only at the edge of the pool and the outer edges of the walkway. A. Find the length of non-skid strips that is needed for the job. Okay, so we need non-skid strips along only at the edge of the pool, so along here, and at the outer edges of the walkway and here. Okay, so let's find the perimeter of all of that and how much we will need. So let's start with the inside. So we have 50 meters by 15 meters. So then this is also 50 and this is also 15. So we would add 50 meters plus 50 meters plus 15 meters plus 15 meters. Plus, we need to do the outside. So we have 90 meters by 25, but this is also 90 meters, and this is also 25. So 90 meters plus 90 meters plus 25 meters plus 25 meters. So that would account for all of the length around the outside of the pool and around the outside of the walkway. So we would have 100 meters plus, these two would be 30 meters, plus 180 meters, plus 50 meters. So let's add all of those together. Let's see, we have 130 meters plus 180 plus 50 would be 230 meters. 130 plus 230 would be 360 meters. So find the length, 360 meters would be needed for the job. B, the non-skid strips are sold only in rolls of 50 meters. How many rolls needs to be purchased for the job? So we need 360, they're sold in 50 meters. So let's do 360 divided by 50, so we can figure out how many we'll need. 50 can't go into 3 or 36, but I could go into 360. Let's see, let's try 50 times 7 would be 350. So it can go in 7 times with 10 left over. And 10, so 7 and 10/50ths or 7 and 1/5. We would need 7 and 1/5 rolls. But think about it, when you go to the store, you can't buy a fifth of a roll. You have to buy a whole another roll. So we're going to need 8 whole rolls to fill out the whole job. 8 rolls are needed. Number 3, a homeowner called in a painter to paint the walls and ceiling of a bedroom. His bedroom is 18 feet long, 12 feet wide, and 8 feet high. The room has 2 doors, each 3 feet by 7 feet, and 3 windows, each 3 feet by 5 feet. The doors and windows will not be painted. A gallon of paint can cover 300 square feet. A hired painter claims he needs a minimum of 4 gallons. Show that his estimate is too high. All right, that's a lot of information, so let's break it down here, okay? So I'm going to draw the walls of the bedroom. I'm going to start by doing that so I can kind of visualize it. So we have a wall, one long wall, one short wall, and actually 2 of each of them. I'm just going to draw 1 of each. So his bedroom is 18 feet long, 8 feet high, and the other wall is 12 feet long and 8 feet high, and there's 2 of each of these. Let's see, it says the room has 2 doors, so there's a door, each 3 feet by 7 feet, and 3 windows, each 3 feet by 5 feet. So 3 by 5, 3 by 5, 3 by 5, and I'm just going to add an extra door so we can visualize it. And you know what? I'm going to go ahead and draw the other 2 walls. This way up, just so we don't get confused. 8 by 18 and 8 by 12. Okay, so these are all the walls of his bedroom. Let's figure out the surface area of these walls and how much paint is going to be needed and go from there. So let's start with the larger 8 by 18 ones. So we have 8 by 18 2 times. Let's figure out what 18 times 8 is. 8 times 1 is 8, plus 1 is 6. So 144, we have 2 of those. Are the feet squared? Yeah. And then we have the short walls. So these shorter walls that are 8 by 12, 2 of them. So what's 12 times 8? 96. You can just check it. 96 feet squared, and another one. So altogether, the walls, we have 144 plus 144 will give us 288 plus 96, 14, 384 plus 1 more 96 will give us 480 feet squared. And the last piece of the room that we need to get is the ceiling, because he wants to also paint the ceiling. So if the bedroom is 18 feet long and 12 feet wide, the ceiling is going to be 18 by 12. So this is the ceiling. So let's do 18 times 12 would be 216 feet squared. So let's add the 216 feet squared for the ceiling. And we get 696 square feet for the total area. Now what we need to do is take out the doors and the windows, because we're not painting the doors and the windows. We had 3 windows that are 3 by 5. So 3 windows that are 3 by 5. So 1 window would be 15. 15 times 3 of them, so that's 45 feet squared that we don't need to paint. And then we had 2 doors that were each 7 by 3 right there. Just erased it. That's okay. The door is still 7 by 3. Which is 21, but 2 of them would be 42 square feet that we don't need to paint. So together, the 45 plus the 42 is 87 square feet that doesn't need to be painted. So we can take that out of the total. So let's do 696 minus 87. 16 minus 7 is 9. So we need to paint 609 square feet. Okay. So we're one step closer here. What was the question again? Okay. It says the doors and windows will not be painted. A gallon of paint can cover 300 square feet. So 1 gallon covers 300 square feet. We have 609 square feet. A hired painter claims that he needs a minimum of 4 gallons. Show that his estimate's too high. Well, 4 gallons would be 1,200 square feet, right? So that's going to be way too big. So 4 gallons is, quote, 1,200 square feet. We only need to cover 609 square feet. So would 2 gallons be enough? 2 times 300 would only be 600. So we'd need 3. We would need 3 gallons. We'd only need 3 gallons because 3 times 300 equals 900 square feet, which is enough to cover 609 square feet. All right, number 4, Teresa won a gardening contest and was awarded a roll of deer-proof fencing. The fencing is 36 feet long. She and her husband John discuss how to best use the fencing to make a rectangular garden. They agree that they should only use whole numbers of feet for the length and width of the garden. What are all the possible dimensions of the garden? All right, so she won a contest. She gets 36 feet of fencing. She wants to know how to best use it for her garden, and we need to find all the possible dimensions of the garden. Okay, so I'm running out of room here. Let's make a chart of, let's call it length of garden and width of garden. And we can discover all the possibilities. I'm just going to make a bunch of lines. I don't know how many I'll need. Maybe I'll need more, maybe I'll need less. Okay. So I'm going to start out with one that's really long and skinny. Now it says, thankfully, they should only use whole numbers of feet for length and width. So the smallest width we could possibly have is 1. So if each of these were 1, and we can have we have 36 to use. If I take away 2, I'm left with 34, and that 34 I can split between these two sides. So 34 divided by 2 is 17. So each of these sides would be 17. So there's one possibility, a width of 1 and length of 17. So if I wanted to expand it a little bit and make it a little bit bigger, so say I made these two sides 2, so made the width 2, and I did 36 minus 2, or sorry, each side would be 2, so minus 4. I'd have 32 left. If I divide that by 2, I get 16. So now each side is 16. If I wanted my width to be 3, I'm just going to keep going. So a little bit wider. 3, that would leave me with 36 minus 6 is 30. And I divide that by 2. Each side is 15. Are you seeing a pattern here? So when we increase the width of the garden by 1, the length of the garden decreases by 1. So I'm just going to continue the pattern in here. So 5 minus plus 1, the width is 6, the length would be 12. The width is 7, we would have 11. If it's 8, we'd have 10. And if it's 9, we would have 9. So if I kept going and went to 10, I would have 8. But if you notice, we've already done 8 by 10 just in the backwards version. So if I were to keep going, I would just repeat all of these numbers, but they're opposite. So I'm going to not do that. So these would be all the possibilities right here. So those are all the possibilities of the dimensions. Which plan yields the maximum area for the garden? Which plan yields the minimum area? So let's find the area. So area is length times width. So 117 times 1, that would be 17. This would be 16 times 2 is 32. 15 times 3, that would be 45. 14 times 4, the area of 14 times 4 is 56. 13 times 5 is 65. 12 times 6 is 72. 11 times 7 is 77. 10 times 8 is 80. And 9 times 9 is 81. So which one has the smallest area and which one has the largest area? Well, the smallest area is 17 and the largest is 81. So which plan yields the maximum? So maximum would be 9 by 9, which was 81. Minimum was 1 by 17, which was 17. So there's the minimum, there's the maximum. Number 5, write and then solve the equation to find the missing value below. So we've given the area, we know the length, we don't know the width. And it's the area of a square, or a rectangle, we don't know if it's a square. And we know that the area of a rectangle is equal to length times width is equal to area. So the length is 1.4, 1 4/10. We don't know the width is equal to 1 82/100. So the way we can solve this is to get W alone, get the width alone. So since I multiplied, I'm going to do the opposite to get rid of it. So divided by 1 4/10. What I do to that side, I need to do to the other side. So we have 1 82/100 divided by 1 4/10. So what I'm going to do is move the decimal point 1 place to the right and bring it straight up. And now I can just think of it as 182 divided by 14. So 14 can't go into 1, but it goes into 18 once. I'll subtract 14, 4, bring down the 2. 14 goes into 42 3 times. 3 times 14 is 42. So there's nothing to bring down, no remainder, so I get 1 3/10. So the width is equal to 1 3/10 meters. Okay, number 6, challenge. This is a drawing of the flag of the Republic of the Congo. The area of this flag is 3 3/4 feet squared. Using the area formula, tell how you would determine the value of the base. The figure is not drawn to scale. Okay, so again, we know that length times width is equal to area of a rectangle. So we know that the length is x plus 1.5. So x plus 1.5 times the width here is 1.5. Is equal to, they told us the area is 3 3/4. So there's the area formula. That's how I would figure out the value of the base. So B, using what you found in part A, determine the missing value of the base. So now we just need to solve this. So x plus 1.5 times 1.5 I'm going to rearrange it a little bit. It's equal to 3 3/4. So I'm going to start by dividing by 1.5 so I can get rid of 1.5. So if I divide that by 1.5, I get x plus 1.5 is equal to 3 3/4 divided by 1.5. Write that again. I'll do it in different colors. So 3 3/4 divided by 1.5. We need to solve this to remember how to divide fractions. So we're going to first make them into improper fractions. So 3 3/4 would be equal to 3 times 4 is 12 plus 3 15/4 divided by 1.5 is equal to 3/2. But if we want to solve this quickly, we're going to flip and multiply. So we're going to flip the second one and multiply. So we'll actually have 15/4 times 2/3. We get 30/12. 30/12 is equal to 12 goes into 30 twice. It's 24. 30 minus 24 is 6/12. So 2 6/12, which is equal to 2.5. So this is equal to 2.5. So we have x plus 1.5 equals 2.5. So now I want to get x by itself, so I'm going to subtract 1.5. And 2.5 minus 1.5 is 1. So that means x is equal to 1. And it looks like we're talking feet. So x is equal to 1 foot.